On behalf of organizers, I will talk a little bit on the concept of this session. I'm a former Vice President Keisuke Hanaki from Science Council of Japan. This is a list of session organizers starting from UNESCO, ICSU, UNEP, IRP, Science Council of Japan, Office of the Chief Science and Technology Officer, Singapore. Okay, I would like to talk on overall background, why we propose this thematic session. Everybody understands that sustainable development goals are important, and for achieving such sustainable development goals, sustainable natural resources management are essential, especially for human well-being, environmental, and economy, and it is key to achieve SDGs. From the viewpoint of SDGs, current production and consumption pattern or systems must be changed, otherwise we can never achieve SDGs. But there are several major conflicts. One is unequal access to resources and negative impact about natural resources. The second one is we are observing global population increase and economic growth. How to manage natural resources under such situation are not really easy task. And we need necessary actions for a peaceful future. One is transformation of natural resource management. We have to change our style. The second one is policy based on scientific evidences for better natural resources management. I have listed here a typical resources. A lineup of resources are shown on your left-hand side, and we can divide resources into renewable resources, in which we can use such resources within renewable capacity. And the other type of resources, non-renewable resources, we can use with care of resource reserves, how much you have in resources. Forest, food, water are typical renewable resources. Energy include both renewable and non-renewable, that's fossil fuel resources. Metals and minerals are non-renewable. And all of these resources are used in various sectors in our society, starting from industry, commercial, and household. And industry, commercial, and household has interaction, and economic and social systems are behind such industry and commercial household. So in order to have better natural resource management, you have to look at everything together. One word which is important is Nexus approach. You have to look at forest, food, water, energy, metals, minerals together. Especially food, water, energy are typical important resources which you need Nexus approach. And integrated policy is important where we have to think about resources as well as industry, commercial, household, and economic and social system. We have to look everything together. Now regarding natural resource management, there are several worldwide initiatives. I am listed here two cases. One is International Resource Panel, IRP. This IRP is doing scientific assessment toward sustainable use of natural resource on themes of land use and source, decoupling from economic growth, cities, trade, red plus, metals, water, food, environmental impact. They are looking everything together. And Future Earth is promoting various knowledge action networks, we call it CAN, and there are two CANs are related with today's topic. One is Water, Energy, Food Nexus CAN. The other one is Systems of Sustainable Consumption and Production CAN. This is a figure from IRP, International Research Panel. There is a challenge of decoupling between or among human well-being, economic growth, and resource use and environmental impact. Decreasing resource use is very hard. However, decreasing environmental impact is possible. So we have to manage both resource use and environmental impact under the growth of human well-being and economic activity. On the other hand, we have to look at local situation. Local security is also difficult situation in some of the countries, including Singapore and Japan, where unequal distribution of resources and population are reason of such a problem. International trade of resources, such as food, are necessary to fulfill requirement. However, such trade brings global efficiency, but local security of food or water is questionable. So there are dilemma between global efficiency and local independency or security. Sustainable consumption and production are also challenges. There are several difficulties. One is you need feedback from consumption side to production side. That is necessary. Sustainable production is being developed. However, such sustainable production must go with sustainable consumption. Otherwise, it doesn't work. In such sense, sustainable consumption, including behavioral change of consumer, is necessary. That's not easy when you compare with industrial improvement. For that purpose, economic incentive or disincentive should be given to people doing the sustainable consumption behavior. Policy advices, everybody understand that is necessary, but there are also a couple of challenges. One is integrated policy. It's necessary, everybody agree. However, there is traditional sectionalisms of each government, starting from worldwide government or national government or local government. And there are conflicts of interest among different stakeholders. And we need scientific evidences of sustainable resource management that will be behind such integrated policy. I would like to add one thing about information and communication technology, what we can do from using ICT. ICT can reduce material consumption by conversion from materials to service. Typical cases you observe is e-book and photograph. Now almost everybody see photograph on screen, not paper. And distance medical education service are also important. Improvement of equity or fuel consumption reduction. In today's plenary panel upstairs, there was a discussion on recovery from destroyed society. One method mentioned there is distant learning, right? When schools are destroyed, such ICT can play a very important role as well. And sharing economy is being developed now very much. And sharing economy include car sharing or sharing office. By using that, we can decrease ownership. It means we can decrease resource consumption. And these ICT can decrease material consumption. And ICT can improve supply chain management in consumer side. Reduction of production loss, such as food loss, is a really big issue worldwide. Many stores sell food, but maybe 20 or 30% of food are just discarded because of the expiration of date. We can reduce such a kind of loss of food. Food is typical natural resources. Okay, these are introduction, and I am introducing quickly panel today. We have moderator, Dr. Philip Carter, and Professor Andras Sozzoni Nagy. and Ms. Ong B. Leng Mei, Dr. Patrick Schrader, and finally, we will have closing remark by Gordon McBean. He's the president of ICSU. Okay, I would like to ask Philip to take chair.
Thank you, Dr. Hanaki, for a great introduction. Our next speaker is Professor Andras Loshi-Nagy. He's a Professor of Sustainable Water Management at the National University of Public Service in Budapest, and he's also President of the Institute for Sustainable Development Studies. He is Chair of the Board of the International Sustainable Water Futures Programme, which is located a little bit close to New Zealand in Brisbane, Australia. Andras, up to you.
Thank you very much, Philip. Ladies and gentlemen, as opposed to my usual habit in the classroom, where I use at least 120 PowerPoint slides, I will only use 2, driven by the recognitions that if I had 120, probably the audience will be happily sleeping. And I would like to send home a couple of important messages. First of all, I'm also coming from the Future Earth program. The Future Earth program has the Future Water, which is done in Brisbane, as Philip has mentioned. And we deal with the global modeling of the hydrological cycle and the water cycle. To follow the title of the session, I think the principal take-home message is as follows. To have a peaceful future, the sine qua non of all our action is to make this world sustainable by 2030, which it certainly isn't. Bear with me that I will transform a little bit the 17 sustainable development goals, and this is perhaps a professional bias, by making a transformation which is topologically, so to say, non-conform, as it puts water into the middle of the Sustainable Development Goals. If you pose yourself the question, what is the SDG goal that you take out from the system of the 17 goals, and the system collapses? That is water. And through water, the connections to the other goals, what we call Nexus. Normally, people talk about the water security, food security, energy security nexus. But there are other nexi that are very strongly linked to water, namely water, disasters, and political security. Or another one, water, climate, and public health. I think at this particular forum, we need to ask ourselves the question, what is it that science can do to make this globe sustainable? We all know that water and energy are mutually interdependent. Energy depends on water and vice versa. Hydropower is the largest renewable source of energy. 20% of all the energy produced is coming from hydropower. There are some countries which are entirely depending upon hydropower, almost entirely, such as Norway, 96%, or Brazil, 90%. If we focus now, and this is what I would like to drive at, if we focus on the case of the developing countries, particularly Africa, one will see that the situation there is quite dire. Africa has huge hydropower potentials, yet it's only 6.2% that is being utilized. And Africa needs energy, otherwise there will be no economic development and there will be no peace and prosperity in Africa. If you look at the other side, how much energy water supply is using, if you look at the municipal bills, 40% of the municipal bills are due to energy. Pumping costs, the distribution system, driving the whole water supply and sanitation system is very, very energy intensive. If you look at the third dimension of this nexus, which is the food security, then one has to recognize that 80% of the water use is by and through the agriculture and the food production industry. What does this mean? It means that due to the triple exponential population growth which we have observed in the 20th century, namely that at the beginning we had 2 billion human beings, at the end we had 6 billion human beings, and the increase was threefold. In the same period, water withdrawal from surface waters and groundwaters was sixfold. There is a growing gap that shows that water management as we do it today is not sustainable. Another figure that perhaps illustrates the seriousness of the situation. In 1950, we had 8 cities in the world that exceeded the population of 5 million. We have 80 now. Nearly 70% of the world population is living in cities. And that's a totally different game in every regard, including the social components. The big drivers are, as they say, the 3 Ps: population, pollution, and poverty. These are 3 main drivers that are, and also the corrupt political regimes and wars that are behind the mass migration which we are seeing now. Out of 8 Africans who are migrating, 1 is coming to Europe, and the 7 others are going to migrate within Africa elsewhere. Global changes, not only climate change, but population changes and other, had major impacts on the hydrological cycle. Ever since the Industrial Revolution, the carbon dioxide release has been exponentially increasing. As a net result of it, ever since we have regular meteorological observations, we observe a linear increase in the global temperatures. And also we observe an exponential increase similar to the population increase in nitrogen fluxes to coastal zone. We see an exponential increase in the loss of tropical rainforest and woodland. We also see an exponential decay in the species extension. We also see an exponential increase in the number of McDonald's restaurants. What does this mean? It means that age-old hypothesis, what the generations of scientists and engineers were grown up, namely that of stationarity, is not true anymore. Stationarity is basically dead. The future is not going to be the same as the past. We have structures around us which are built up against certain design values. For instance, a 100-year flood, which means that they are providing security against a flood that, statistically speaking, occurs once in 100 years. A few years back, there was a huge flood in Central Europe, so big that it had flooded the metro system in Prague, and that was knocked out of operation for nearly 6 months. At that time, I was working for UNESCO and was invited to a press conference, and one of the journalists asked me the question, how often such a huge flood is occurring? I said, well, I learned it from the Czech hydrologist that this was a flood of 200 years, which means, statistically speaking, it occurs once in 200 years. The journalist went on, he said, yes, but last year we also had a 200-year flood. I told him that our design methods are based on independent samples, identically distributed, and are not correlated at all, annual maxima. So it could happen that the last year flood happened in the very last year of the previous 200 years, while the one what we have now is happens in the first year of the next 200 years. Statistically speaking, this is a very plausible explanation. And he said, this is fine, but the year before the last one, we also had a 200-year flood. And that is very difficult to explain. And the moral of the story, and this is a huge task for the science community, the mathematicians, statisticians, and hydrologists, how to come up with a new toolbox, a new design box that is able to consider the non-stationarity, which is caused either by human intervention or by climatic variability and change, or the linear combination of both. One of the things what is often what you found in the daily news, that, you know, breaking news, the climate is changing. Well, the climate is not exactly fresh news, because the climate is changing for 4 billion years. What is news is that it changes somewhat differently and due to human activities, plus the geodynamical changes. The big issue here is, and this is the hypothesis that our profession is trying to look at closely. Is it true that the hydrological cycle is changing? Is it true that the circulation of the water vapor in the atmosphere and over the land and under the ground, that circulation is speeding up? Because if it is true, then the probability of the occurrence of the extremes will increase. That is to say, we will have more extremes on the positive flow side. That is to say, we will have more floods, more frequent and higher in altitude. But at the same time, to keep the first law of thermodynamics at work, we will have more droughts, both in its spatial and its temporal distribution. And we are not prepared to do that. Because to have adaptation systems, storage reservoirs, and systems that cope with this uncertainty, that takes decades to build up. So we have to start coping with that. Now, will this cause an increased risk for humanity? Here, particularly in the arid region, will they run out of water? Well, they will not run out of water, but the amount of water will be further decreased dramatically in response to the climatic variability. And it certainly will cause an increase in vulnerability. Will there be more disasters in stock? Yes, there will be, and we have to prepare ourselves for that. Will there be less water for people? This is not a question, it's a fact. If you look at the past 40 years, in 1975, the per capita water availability, grosso modo, globally, was about 15,000 cubic meter per person per year. Today, it's down to 5,000. So there is of course, you cannot look at this linear trend and then just simply continue it and say that in yet another 35 years we will run out of water, because the system is a cycle. Where is the problem? The problem is whether are we running out of water, or the problem is how we govern water. What are the institutions which we are using? What are the legal mechanisms? What is the science what we are using? And here is the problem, that there is a huge gap between science and policy in today when it comes to water. Policies, and I must say politics, are often based on outdated science. Over the past 25 to 30 years, there has been an incredible progress in the application of our science. Mid-90s, not only the internet revolution, but basically the computational barrier was gone. So we can compute almost anything and through the number crunching. I'm not talking about quantum scale, but mesoscale, which is our scale. So climate change, which is happening, it's not a matter of religious discussion. This is a scientific fact, which nobody can deny. 80% of climate change, ladies and gentlemen, is manifested through, with, and by water. So it is water management, sustainable water management, that provides us the coping capability to deal with climate. It took humanity 250 years to screw up the climate. In order to restore it by mitigating the release of greenhouse gases into the atmosphere, it will take a few years, if not 100 years, provided that politicians will stick to the Paris Agreement. And there are some who are not exactly in that club. So what we have remaining is essentially adaptation. And adaptation is through, with, and by water. So sustainability is essentially a water issue, whereby we need to increase our resilience. Security depends, future security, political security as well, depends on how resilient systems we will have. We will need more storage. Very controversial topic. Imagine a situation of an upstream, downstream country. If an upstream country is building up a reservoir, the downstream country is very unhappy because they say that you guys are stealing our water. How do you find an equilibrium between the two? How do you build up a joint vision, the subject, or an object rather, which is seen from different angles, yet the parties are speaking about the same thing? The situation here, Mr. Chairman, is particularly critical in Jordan. I mentioned this, 15,000 today, 5,000 cubic meter. In Jordan, the per capita water availability is 120 cubic meters per person per year, versus Canada, 120,000 cubic meter per person per year. Now, ever since we have the migration crisis, the Syrians and the Iraqis are coming in, Jordan's per capita water availability has dropped down to 70 cubic meter per person per year. And that requires international cooperation and solidarity. At the end, Mr. Chairman, we are approaching our planetary boundaries. According to some, Jan Röckström, my friend in Sweden, at the Resilience Institute, he concluded that we are beyond the tipping point, beyond the planetary boundaries in terms of climate change and in terms of biodiversity loss. And in water, we are approaching there. We have a very limited amount of fresh water, 97.5% of the water being in oceans and seas, and the rest of the 2.5%, 60% of which is frozen. What remains of 90% is underground, and what we have there up is a very, very tiny quantity, 0.007% of the total water resources. This is what the hydrologists call the James Bond phenomena. 0.007% of the total water resources is available for human consumption in lakes, reservoirs. Added to that is the disasters. 90% of the disasters are water related. And here, the only hope humanity has is science. Not only natural sciences, but also social sciences. And it's really a heartwarming news that the environment and natural sciences and social scientists are now getting together, because there is a task which we can solve only together. Thank you, sir.
Thank you, Andres. You paint a particularly grim picture. Are there any positive signs that we can see?
Well, the positive sign, the hydrologists used to say, we don't bring the subject of research. Yes, there is, because it all depends on us. It all depends on what sort of policies we are making. This is why I try to emphasize that this is not a fate that is inevitable, but it's a matter of choice. What sort of governance structure we use, what sort of governance mechanism we use. And there, observations and scientific analysis are of extreme importance. I mentioned the other day that today, unfortunately, some countries are still using water data as secret or classified data. Now, with the modern technology of Earth observation systems, that secrecy, data secrecy, will be gone. Because we are not only able to measure through Doppler radars the velocity of flows, but through three-dimensional digital models, we are able to measure the topography of the riverbeds, and thereby we are able to estimate the discharge, which so far was in many cases a classified data. So science is helping a great deal to build peace in that regard.
But we'll also need agreement on the interpretation of that data?
That's right, and that is one of the objectives of the Future Earth program, including within that the freshwater, the Future Water program. We are now able to simulate the hydrological system at a mesh of 2 kilometers. So the grid size is 2 by 2 kilometers. When I was a grad student, we had 500 by 500 kilometers resolution. We have never even dreamt about this. So the progress that, this is what I'm arguing with, the progress that has taken place over the past 30 years is mind-boggling. And I hope that the politicians will learn about it.
Are there any questions from the floor? Do we have a microphone? Thank you. It is better.
Excuse me.
I do, but they don't.
Okay, thank you. My name is Zakaria Fouad. I am professor in the National Research Center in Agriculture and the Biological Division. I am from Egypt. First of all, I would like to thank you very much for your excellent presentation and for very important points nowadays and in the future about climate change, global warming, and how to sustainability of the water resources. Actually, the water resources in Arab region, in Egypt, Jordan, and many Arab countries is very low compared with European countries. Also for this point, I would like to focus about water footprint. Water footprint. Yeah. Water footprint. It's a very serious problem because if I know now 1 kilogram for meat should be cost about 10,000 liter, so we can change by another product. This, for example, but should be focused about water footprint. I would like to know more information about water footprint and how to do and what should we do about this issue. Thank you so much.
Well, thank you so much for this question. I hope I will not hurt anybody here in the audience. I think water footprinting is extremely important as a tool to communicate the message, but not as a tool that could be used as a basis of scientific planning. You know, when you drink a cup of coffee, you have to know that there are 100 cubic meters of water behind that, and this is somewhat shocking. You also know that with the largest country in the world in terms of population, there is a social transition. More and more people are moving towards the middle class. Therefore, their diet is changing. And in China, the usual diet, what they used to have, is changing dramatically. And that means that the footprint is huge. The water footprint is huge. And they have to move elsewhere, Africa and other places, to provide the necessary food. Like I said, I think it's a very important tool, but it's a communication tool. So the public, and particularly the politicians, would understand what is the impact of using so much water.
Okay, I think we'll just leave it there, Andres. Yeah. Thank you very much. Can we just leave it till the end?
Okay.
Yeah, that'd be great. Thanks.
Thank you.
Our next speaker is Ms. May. She's a director of the Unconventional Threats in the Office of the Chief Science and Technology Officer, the Ministry of Home Affairs in Singapore. She's responsible for a network of scientific facilities and has introduced on-site screening and analysis capability for security, for sensitive materials, for border surveillance in Singapore. Ms. May.
Thank you. Good morning, everyone. First, I'd like to thank the organizer of World Science Forum for having Singapore here today to share with you on our story on how we sustain water, energy, and food resources. I definitely have more than 2 slides. Please bear with me. I'm not that skilled to carry my message across with 2 slides. Let me start off with a quote from our Minister of Foreign Affairs, Dr. Vivian Balakrishnan. He told the audience at the innovation events that what you see in Singapore today is an exercise of desperate imagination. It's not about innovation because it's sexy, but because it's about survival. The Singapore seen today by many look good and sexy, but to many of the Singaporeans, we do worry about water supplies when we have dry weather and the importation of food when there's a catastrophe somewhere around the corner of the world. Being a country with no natural resources, we are here today not by chance. This picture shows the city landscapes of Singapore. It's always sunny in Singapore. We have 365 days of summer with high humidity and rainfall. We are also one of the countries that experience the highest frequencies of lightnings. Our Minister for Foreign Affairs, Dr. Vivian Balakrishnan, also mentions that we are not supposed to be here. What you see today of Singapore is really a case of trying to sustain many things on a small island that is represented by a dot on the world map. We call ourselves the little red dot because of the reds on our flag. Singapore lies 1 degree north of the equator at the southern tips of Peninsular Malaysia, with a landmass of 582 kilometers square. Imagine an island 150 times smaller than the Hashemite kingdoms of Jordan. Singapore has little to no natural resources. When Singapore gained our independence in 1965, it was faced with many major challenges that brought its survival into question. We had a water agreement with Malaysia. We import more than 90% of our food, and our electricity at home is a result of power plants fueled by imported gas. In present-day Singapore, its landmass has increased by more than a quarter as a result of land reclamation. In addition to the increase in landmass, its population jumped threefold to 5.6 million today. Much of our land has been used for the people housing needs and industrial development. As such, in a country like Singapore, where land is premium, it is imperative to integrate the use of land for socio-economic growth. Let us take some time to define sustainability. The original definition of sustainability is considered to be meeting the needs of the present without compromising the ability of future generations to meet their own. Singapore takes on sustainability is a balance between economic, social, and environmental priority to achieve growth. We are also always reminded to think about the future generation when we make major decisions on embracing certain types of technology and also the use of land. And speaking of water, which is our biggest concern, water is everywhere, but not really drinkable everywhere. Now I would like to share with you a production by our Public Utility Board. This video is about interaction between a grandson and a grandfather. And grandfather in Chinese is known as Agong. So please enjoy this short video clip of 1 minute.
Agong says, it has not rained for days. Agong says, long time ago, rain did not come for many days too. Life was difficult then. Will we run out of water again? But Agong says, we are very lucky today. Now we have 4 sources of water supply. But Agong always says, if we don't save, there will never be enough water.
There is a message sent to all Singaporeans on our national TV on the need to save water. It took on an emotional slant to move audience to appreciate the values of water in Singapore and why it's important to make every drop count and use only what you need. Today, the 4 tabs tell the Singapore story for our water story, namely the reservoir, which is our catchment area, our imported water, our new water, and desalinated water, and how we ensure sustainability in our water supply. Since 2011, the water catchment area has increased from half to 2/3 of Singapore land surface through a network of rivers, canals, and drains. Rains that fall on Singapore is channeled to 17 reservoirs before it is treated for potable water. Singapore is one of the few countries to harvest urban stormwater on a large-scale basis as its water supply. Another step in enhancing the sustainability of our water supply and building resilient against drought is desalination. 2016 was the hottest years on record globally due to the very strong El Nino effect. The Lingua Reservoir in Johor, where Singapore imported water from, was also found to be at its new historic low. Hence, there is a pressing need for Singapore to move towards a more reliable water supply. There are currently 2 desalination plants in Singapore that meet up to 25% of Singapore's current water demand. The 3rd desalination plant is expected to be completed by this year and the 4th by 2020. Last but not least, we attempt to give the used water from the residential area a new leash of life by channeling part of the used water to the new water plant. The treated new water is mixed with the water from the reservoir and through water purification process for supplies to the industrial and residential area. The 5 new water plants that Singapore has today can now meet up to 40% of the nation's current water need, and by 2060, it is expected to meet 55% of Singapore's future water demand. However, simply enhancing supply is not sustainable. There's a need to manage water demand as well. Singapore ensure that water as a resource is rightly priced. This way, we send the correct signal for conservation and efficiency. Far from being just a factor of production, energy is a vital resource for all aspects of modern living. It goes without saying, we need energy to light our homes, power our transport system, and grow our industry. Singapore is dependent on imports of oil and gas for our energy need. We import 80% of our needs from neighboring countries through gas pipelines. In the first quarter of 2017, natural gas accounted for 95.2% of fuel mix. Other energy products such as biomass and output from solar accounted for 3%, while the rest was contributed by coal and petroleum products, mainly in the form of diesels and fuel oil. As illustrated, Singapore is moving away from traditional energy source and towards natural gas. To ensure natural gas as a reliable and secure energy source, Singapore has built a liquefied natural gas terminal to import natural gas from as far as Trinidad and Tobago. When condensed, the volume of LNG reduced by 600 times, which makes it cost efficient to transport over long distance. In addition, LNG emits half the amount of carbon dioxide compared to coal for the same amount of energy generated. Singapore's 4th LNG storage tank is slated to be completed in 2018 at 260,000 meter cube. This new storage tank will be among the largest in the world and will increase Singapore's throughput capacity from 6 million to around 11 million tons per annum. Coupled with ongoing efforts to build a 2nd LNG terminal, this makes natural gas critical to Singapore energy security. On the journey to explore renewable energy, we realize that we do not have geothermal energy sources such as volcano, but we count our blessing for that. Commercial wind turbines operate at a wind speed above 4.5 meters per second, but the average wind speed of Singapore is only about 2 meters per second. Hydroelectric power cannot be harnessed as Singapore does not have a river system with fast-flowing water. Nevertheless, solar energy remains the most viable renewable energy options for Singapore. Solar deployment in Singapore require innovation urban thinking given our limited land space. Heavy crowd cover and urban shading poses challenges such as intermittency. This is where the Solar Nova programs comes in. The Solar Nova program is a whole of government effort to accelerate the deployment of solar photovoltaic system in Singapore. Ongoing research is being conducted to integrate PV panels into buildings, such as mounting on the rooftop, panel in the building facade in a creative and aesthetically pleasing manner. Reservoir real estate is another area of largely untapped potential. Singapore has installed the largest floating solar PV panel located in Tengai Reservoir, covering 3 hectares of the reservoir surface. This pilot project, which completed just last year, produced enough energy to power 760 homes for a year. These floating solar panels have the potential to reduce evaporative losses from our reservoir. The efficiency of the solar panel are improved when installed over water, as the cooling effect will allow them to yield more energy compared to solar panels that are too hot. On our way forward, solar energy is never able to meet our base load, Singapore is always on the lookout for an alternative energy source. One promising idea is harvesting ions from cosmic ray, an old forgotten invention. Research has demonstrated that high voltage electricity harvested from airborne ion can power lights, motors, and produce hydrogen and oxygen gas via water electrolysis. Just like our water and energy supply, Singapore imports more than 90% of our food. The question now is, how can Singapore push the technological boundary to increase our local food production? A public-private partnership has led to the development of a successful vertical farming in Singapore. And the persistence of social entrepreneurs led to Singapore's first commercial rooftop farm in our shopping belts. Using vertical growing techniques to cultivate herbs and vegetables on a 6,000 square foot roof in downtown Singapore, Comcrops grows its crops in a vertical rack that draws waters and nutrients from fish waste in water tank containing tilapia. Vertical farming is growing in Singapore from just one vertical farm in 2012. Today, we have 7 licensed vertical farms producing vegetables, fish, and crab. This farm uses high-tech and high-yield methods to overcome limitation of traditional farming and transform their work in lucrative business. Example, Sky Green. Running at full capacity today, the farm is producing 5,000 to 10,000 kgs of vegetables in a day. Gill and Craw, another vertical farming example in Singapore, fatten up Sri Lanka mud crab that are bred in hatchery and sell to crab dealers and restaurants. Owing to the large amount of importation and movement of conveyances in and out of the country, and also for transshipment, as Singapore is one of the major transport hubs in the region, I would like now to share with the audience how we protect our resources together with economical growth. The map here shows the network of scientific laboratories dotted around the island, which are set up and has game-changed the way we conduct our border operation. The labs are instrumental in bringing science and technology capability into our frontline operations, such as in the detection of security-sensitive material to enhance border security. Our network of scientific laboratory comprises of 3 operational CBRNE laboratories, 1 DNA profiling labs, and a CBRE training school. The network of laboratories are strategically located at the north, south, western, and eastern parts of the country so that we could provide quick response and make unknown known for better operational decisions at the border. All the laboratories presented on this map also conduct evaluation, screening, and investigation work to support our inland investigation based on a sectorial framework. Like many countries, Singapore is not immune to ill intent or terrorist attack. Against the backdrop of threat, we take the all-hazard approach when we counter threats at our border, as well as between the country. At the Office of the Chief Science and Technology Officer, our expertise in CBRNE lends itself very well in the support of border security operation, given that our border is our first line of defense against the entry of threats, whether is it civilian or terrorism threats in nature. The lab equipped frontline operation with the necessary capability to detect security-sensitive material that may be coming through our border, as well as sending a strong deterrent message to would-be smugglers and terrorists. Our border labs at BASIC are all equipped with a chemical and a biological laboratory that allow us to conduct CBRNE screening. The chemistry labs are equipped with state-of-art sample preparation techniques and analytical equipment such as GCMS, LCMS, and the HRMS. This instrumentation setup allows each lab in the network to screen for presence of chemical agents, toxic industrial chemicals, explosive, and a number of precursors. As part of protecting of our resources such as water catchment area, all drivers who enter Singapore via our land checkpoints who are transporting hazardous cargo on our road need to be licensed and certified. They must adhere to a route prescribed to them. This is to reduce the potential runoff of hazardous material into our sewage and catchment area when accidents occur. Besides the deployment of handheld detectors and harnessing technology in the primary tracks, For suspicious cargoes detected at our checkpoint, we adopt a whole test and decant approach. On a daily basis, our scientists and immigration checkpoint officers will screen samples and conduct lab analysis to verify information of cargo declaration and also to verify the control materials are within the import permissible limits. All our biological laboratories are equipped with a lab-on-a-chip platform with the ability to conduct multiplex PCR screening for influenza and bioterrorism agents. The lab also surveys for health concerning pathogens. Our lab leverage very much on the multiplex PCR and microarray platform for fast detection of influenza in our poultry supply. At the border, we also conduct biosurveillance programs to look out for agents such as anthrax, tularemia, plagues, and smallpox. This multiplex PCR platform is 50% faster as compared to traditional PCR technique. Separately, we also use the lab-on-a-chip platform to survey for a list of 15 foodborne pathogens for some of the food coming into our borders. Other capability includes to screen and to determine materials that are suspected to be radioactive or fissionable, and also in identifying the trace substance found together with the nuclear and radiation material. This aid in identifying where the radiation and nuclear material was originated from. To avoid the smuggle of security-sensitive material among our food, such as fishes, we have employed the use of nuclear resinol quadrupole at our fishery port, which can detect illicit materials such as explosive, narcotic material in water. The NQR is able to provide good imaging of security-sensitive material in the presence of water as compared to X-ray system. Similar to the harvesting of ions in the air, the office is also evaluating the use of cosmic ray as an alternative scanning technology to detect stows away. Cosmic ray has proven to be effective in detecting high Z or nuclear radiation material. This is a passive way of conveyances screening which is safe for operators and drivers, and we believe this could possibly pave the way for imaging technology. In summary, Singapore is on a constant lookout for technology, and we look very much into harnessing technology for new ways to build, sustain, and protect our water, food, and energy resources to support our development, economic growth, and for our future generation. We believe the world is always hopeful, and with science, it gives us the means to harvest the hope and wishes to sustain life. With this, I've come to the end of my presentation. Thank you very much.
Thank you, Ms. May. I think in the interest of time, we will save questions to the end. Sure. We'll move on to the next speaker. Our next speaker is Dr. Patrick Schroeder. He's a research fellow at the Institute of Development Studies at the University of Sussex. He has worked extensively in development cooperation programs, especially in China. His research interests relate to the global transition to a circular economy in the context of sustainable consumption and production systems and the Sustainable Development Goals. Patrick.
Yeah, thank you for the introduction. Hello everybody, Assalamu alaikum. Thank you very much to the organizers for inviting me to be here. I'm very honored. Also thank you to the Science Council of Japan, especially. I'll start with a very short introduction to IDS, the Institute of Development Studies. We are an independent think tank based at the campus of the University of Sussex. We had our 50th anniversary last year, and initially it was set up to inform the UK's development policy and the UN, and over time we're still doing this, but we're also a leading academic institute on development studies. And so the three defining challenges of our area to us are reducing inequalities, accelerating sustainability, and building more inclusive and secure society. And often we try to look at these, the three combined. Often it's either sustainability or inequalities which are looked at, or sustainability and security. And I will try to do this in this presentation as well. The other approach that has been mentioned also during the conference here is about co-construction of knowledge. So a transdisciplinary approach which actively involves people not only as objects to be researched, but to directly involve them and enable them, make them change makers to achieve maximum impact. In addition to IDS, I'm also I'm involved in one of the knowledge action networks of the Future Earth network, and as Professor Hanaki already mentioned, is the topic is sustainable consumption and production. And we're trying to look at this as a coupled system. So traditionally these have been looked at separately, production and consumption, but they're actually very closely intertwined. And so we have a number of topics and colleagues in different working groups looking at issues like sustainable lifestyles, and also one of the areas looking at is consumerism. And the research identifies consumerism as an ideology or the social economic order as one of the major drivers for unsustainability or for global environmental change. And so we also see changes in this kind of ideology happening in the US and Europe, Japan, where people are questioning this type of system. And so that's areas we're looking at. And so this CAN is organized and coordinated by the Research Institute for Humanity and Nature in Kyoto. But it involves researchers from, I think, from all continents that we have included so far. So, and how does this link, so this work on development studies and sustainable consumption and production, this links together in SDG number 12, which I've put up here. So you can see here, there's a loop here, which is about closing the loop, and my specific topic is circular economy, which you might have heard of. And I've put up a few targets from the SDG 12. So 12.2, achieve the sustainable management and efficient use of natural resources by 2030, which is a big goal, actually very, very cross-cutting, I think relevant for all the other SDGs as well. Then there's the one here, 12.4, by 2020, achieve the environmentally sound management of chemicals and all wastes. I was always surprised to see it by 2020, because I think that's basically impossible to achieve within 2 years. It's a massive task even to achieve that by 2030, and requires a lot more efforts. Currently, it's only 0.3% of international development funding that goes into addressing waste issues. So to be able to achieve these targets, that needs to be increased significantly. And then one of the other targets, I'm not sure if you can see it, it's 12.5, about substantially reducing waste generation through the 3 R's, prevention, reduction, recycling, and reuse. And I've put up this slide. I'm not sure, for those of you familiar with the circular economy, you might probably know this. This is developed by the Ellen MacArthur Foundations, one of the organizations which have been, over the recent years, promoting the circular economy as one of the strategies to significantly improve resource efficiency. And so it's called butterfly diagram because it's got the 2 wings, and the basic, you can see here's the linear system of consumption and production here. And the important part is, so organics or biological nutrients, the bioeconomy, and so technical nutrients, they need to be kept separate, otherwise the circular economy cannot work. So plastics don't belong here, and like food waste shouldn't go in here, just to as examples. And you can also see, again, consumers here are at the center. So if consumers do not actively participate in this, this cannot work. And so the circular economy is also, you can see, it covers a whole spectrum of industries and sectors. On the one hand, this is SpaceX. It was mentioned also by Professor Kaku. So Elon Musk and his company, they're using circular economy principles. They've, by reusing their rocket fuel boosters, and have significantly reduced costs and resources. Thereby, they've become the most competitive company in this sector. But on the other hand, there's also informal waste pickers, about 15 to 20 million people doing circular economy every day, but in a very different situation. And so at IDS, our concern is mostly about this human aspect, the inequality, and how to find solutions to addressing this. And so we there's a few research questions that we're looking at relating to the circular economy, so which include the relation of the circular economy to the SDGs, and one of the big questions is whether the circular economy can be a more inclusive economy compared to the linear economy. So while we're transforming our current consumption and production systems, can we also address inequality at the same time, rather than just looking at resources? And then there's also the link between the circular economy, the digital revolution, and security issues. Then we're also looking at political economy aspects of the circular economy. Who are going to be the winners, who are going to be the losers, who are the drivers, or who might be actors which are obstructing progress towards this. So for the link between circular economy and SDGs, we've tried to look at all the different 169 targets, and we've identified quite a number of targets to which circular economy and specific circular economy practices can make significant contribution, and so we have them colored here in blue. We also see indirect contributions. For example, circular economy can contribute to economic growth and industrialization. At the same time, it can also then contribute to poverty reduction. So this will be published shortly in the Journal of Industrial Ecology. Together with Tier Fund, one of the UK Christian development organizations, we've looked at specific case studies in different countries, in Ghana, Kenya, India, Brazil, to see how circular economy practices can make positive contributions to livelihoods. And we have examples in terms of biogas in rural Brazil, but also solutions, circular economy solutions to sanitation. Then there's good practices in terms of plastics and e-waste recycling. So we've tried to document these in a short publication that came out last year. So on the one hand, circular economy can make a contribution to developing countries, but there's also possibly a downside to it, as also was mentioned in the conference. So science and technology can cut both ways. So the circular economy possibly also can have negative impact. So I'm not sure if you're familiar with this. This is Liam, a robot developed by Apple to dismantle an iPhone in about a minute or so. And so that's kind of Apple's strategy to become active in the circular economy and to secure resources. However, there might be two problems with this, because second-hand electronics and mobile phones are one of the sources of computers for people in developing countries. So that many people depend on repaired products to get access to the digital world. So if major companies like Apple and the others will tighten their kind of loops, so there won't be this leakage of second-hand electronics and e-waste to developing countries, so that might have negative impacts on like maybe broaden the digital divide. So there's a danger of developing countries falling further behind. The other possible negative impacts relates to consumerism, because there's an issue which is now being called circular economy rebound. So kind of a mechanism like this, where people can swap their phones without having to have a bad conscience about wasting resources, that might actually stimulate further consumption of mobile phones and electronics, which might have a negative impact on overall resource consumption. Then there's also, the reason why linking the digital economy and the circular economy, they're so closely interlinked. So the digital economy depends on a number of critical materials and metals. So in this slide, I'm not sure if it's so clear, but if we continue with business as usual, we will run out of many of these materials within less than 50 years. So to be able to realize the dream of a digital economy, etc., it's necessary to increase the recycling rate of these metals. So if we can, for example, increase to 70%, we can extend the burn-off times and ensure that we have these resources. So that's why the circular economy is, maybe as a criticism or looking at security issues, it's mainly looking at security of resources, not so much at the issues of human security, for example. So this is the text from one of the main EU documents on the circular economy, which mentions security, but as a concern, insecurity of supply of resources and about securing access to raw materials. So that, this is very important, but probably the security discussions around the circular economy might need to be extended to include other humanitarian security concerns. This is now linked. This is a patent which was developed by Amazon about 3D printing and future textiles, and it's again related to consumerism. So the consumer is here. The way this would work is that clothes and shoes, everything is 3D printed, and there's a loop here, very local loop, which might be very resource efficient, especially if it's linked back to the 3D printing. So this is kind of on-demand apparel manufacturing system. But again, there's possibly a negative impact on employment and global textile supply chains, especially looking at women in developing countries. So for many women, these are kind of the first steps to get into clothing manufacturing. So if the Amazon patent will be implemented and our future textile system will be locally based, 3D printed, what will happen to these jobs? And that's an open question. But so the circular economy might actually contribute to this premature deindustrialization, this concept which has been already observed. Danny Roddick has written on this one. Just now coming to an end, I think there may be two main priority issues which should be looked at by the circular economy. One is ocean plastics pollution. That has been big in the news over the last few months or so. The United Nations Environment Assembly has also made this one of the main topics for this year's Environmental Assembly. And so the circular economy can make a huge contribution here. And there's also, on the one hand, it's about it's also an opportunity for natural scientists and social scientists to work together. On the one hand, you need material scientists to develop new types of plastics, which might be biodegradable even in the oceans. We need technical engineering solutions maybe to get plastics back out of the oceans, but we also need political scientists, social scientists to look at the issues around plastic usage in society, to understand why municipal governments are not able to prevent leakage of plastics into oceans. And maybe that could be a topic for the new Science Council to look at. Just very briefly, another issue is open burning of waste, which is common in many developing countries. Actually, it's becoming common again in the UK. There's open dumping and fly tipping that's on the rise. And lots of these emissions are not fully accounted yet in the national emission inventories. So lots of the emissions on waste just look at the methane that's generated in landfill, but the black carbon and other emissions from the open burning, that's not in the statistics. And here the circular economy and behavioral changes, sustainable lifestyles can make a huge contribution. Okay, thank you very much. That's all.
Thanks, Patrick. Just one question. Do you think there's a danger that the circular economy could widen the gap between the haves and the have-nots?
Yes, there's the potential. I think I tried to show that it could actually happen, especially if the circular economy and the digital economy are so closely connected. So it would be very difficult for many low and middle income countries to catch up.
Yeah.
So there's danger. But because the circular economy is still in the transformation, I think we can still design it in a way, because it's all about design, we can design it in a way that this can be prevented.
Okay.
Thank you very much for the presenters. Nazar Hassan from UNESCO. I have 3 questions for our 3 presenters. For Professor Andras, I would like to know, of course, the figure that you gave on the screen was biased if you are a water person. Okay, because if we're talking Nexus, then what I would like to see in the middle are the 3, 6, 7, and I think 3 for agriculture, food security. And then we see how the rest of the SDGs can work around those. But my question is, within developing countries, the issue of building a Nexus project is a huge burden, because in any country, you'll find that you're handling energy through 2, 3, maybe 4 ministries. Water is the same. So what type of policy framework can actually work in bringing together those institutions in form of, for forming a real nexus and work together and get the benefits of this energy out? To Ms. May. It's good what you mentioned about vertical farming, and you said that it was 5,000 kilograms of vegetables a day. I would like to hear about how much electricity or energy and water it consumes per day as well, to see if it's really efficient. And to the last but not least, is circular economy another sexy word for waste management? Okay, and it's really, you're not decoupling economic growth from use of resources, you're just reusing the waste, if I understand it correctly. And if that is not the case, then what is the difference? What is the added value of the word circular economy? Thank you.
Thanks very much. Andres, do you want to start off?
Yeah. Thank you very much. I think the principal problem is with the governance, the institutions. The institutions are fragmented, not only in the developing countries, not only in Africa, but if you look at North America and, or Europe, water is normally handled by 3, 4 ministries. One is the environment, one is the Ministry of Agriculture, the third one is Ministry of Mining, when the subject is the same. So I think we need to integrate the institutions as well. Way back 20 to 30 years, the order of the day was Ministries of Environment, and then you synthesize, you integrate land management, atmosphere, oceans, and water. But perhaps today we ought to move a little bit further down the road and then talk about Ministries for Sustainable Development, where the 3 big pillars of environment, economics, and social could be brought under the same umbrella. Of course, often people mix up governance with management, and there's a major difference. The governance is asking the question, what are the right things to do? Versus management, how do we do things right? And there are 2 totally different questions. Now, if you look at the department, what are the right things to do? Then, what you come to your mind is the rule of law, no corruption policies, gender issues, role of science. And I think one of the most important messages that should come out from conferences like this is the role of science and technology. The past 25 to 30 years witnessed a real revolution. But everything is digital now, except it didn't go through how we are governing and managing our systems. For instance, when it comes to water, I firmly believe that the future belongs to the digital water management. where Singapore is a key point. They have done a fabulous progress to make, you know, a digital city-state, Singapore, by integrating the management of sewage treatment facilities with water supply facilities. So there is an integrated model, and the modeling capabilities and the digital capabilities, they have no limit so far. The only thing which is missing, I believe, and I hope I'm not shooting into the dark, that's the political will. The political will, the capacity to do it, and that's why education is so important, and of course the resources. The first thing politicians normally cut back is the operational cost to hydrometeorological services. Look at Africa. We have more data on the hydrometeorology of Germany than we have on the hydrometeorology of Africa. But that has global consequences because we are calibrating our global circulation models, atmospheric models, and hydrological models against data, but there's a huge continent which is suffering from the lack of appropriate data. And if that's the case, then the marginal risk and uncertainty that's coming out from the models goes up. And that's not only, quote unquote, only a problem for the Africans, but it's a global problem. So data and knowledge on the hydrometeorological services is a common good. It's the interest of all of us to have well-operating services in Africa. That's why we have to invest into Africa. Thanks, Andres. Yes, ma'am?
I do not have data on the power consumption of vertical farming. What I have here is, I think for us, our government try to look at first when we award a piece of rooftop to a particular company for vertical farming. Some of the way which we access this farm land tender will be the ability for you to achieve high productivity level, ability to sustain your business, and ability to, you must have some factors of recycling resources. For example, corn crops. I know this entrepreneur, Alan Lim, very well. Basically, he has a fish that is growing underneath the farm, and the excretion from these fishes is breakdown by, because the water is rich in nitrate, so he has bacteria to break down this nitrate, and the nitrogen, the breakdown from the nitrate, which is the nitrogen in the water, are then piped to the vertical farm as a nutrients for the farm. Yes, so yes, right, as fertilizer. So there's no need to further buy artificial fertilizer to import, and this access the way which is like a self-sustaining system with very little need to use fresh water, yeah, and recycling, yes.
Thank you. Patrick?
Yes, regarding just the circular economy, just about waste management. I mean, I agree there's a hype about the circular economy, and now it's necessary now to demonstrate what the circular economy can deliver. But it's not just about waste management. I mean, when we just say just waste management, actually waste management is a huge issue that needs to be addressed. And so the circular economy will be about waste management, but the overall goal is actually to design out waste, that we don't generate waste, and that should be possible to do so. And it's so far, as scientists, we haven't, or policymakers, we haven't paid enough attention to waste. So if we apply our knowledge, if we apply our innovation to waste, we can create new resources out of this. And so that's the overall kind of goal to address. And then, I mean, within the circular economy, there's so many subfields like repair. Repair will become increasingly important. So far, I think as a society, we have lost many skills in terms of repair of products. We just like take, use, and throw away. That's very wasteful. Then there's business models around remanufacturing. So where, like, for example, big companies are thinking about this, how to get their products back and then remanufacturing to save resources and money. There's other concepts like industrial symbiosis, which is used in China for eco-industrial park development, where companies are put together in a more like symbiotic relationship. The outputs, the waste outputs from one factory can be used as feedstock for others. And I think Singapore is doing things like that as well. So the circular economy is about waste management, but there's a lot more to address as well, and lots more potentials on like circular thinking can be used.
Okay, thank you, Patrick. In the interest of time and lunch, could you, if you have questions, I'm sure the panelists would remain behind to talk with any potential questioners. Can I now call on Professor Gordon McBean, the President of the ICSU, to provide some closing remarks?
Well, thank you very much. I was going to show 52 slides, but I won't now in view of the time. But just to point out that, as we know, there are 17 Sustainable Development Goals, there's 169 targets, and as you, I think, know, sustainable development in principle means to meet the needs of the present while not jeopardizing the needs of those of the future. And so it's very much an issue of seeing the future in a very complex system that is multidimensional. It's a circular economy, but it's also, well, let's say more complicated verbs than that. And I think we need to understand how all of these relationships take place. As the chair noted, I'm the president of ICSU, as he said, but that's actually an old name. We're the International Council for Science, and we are merging with the International Social Science Council to bring together the disciplines of math, physics, chemistry, geology, oceanography, etc., biology, chemistry, since David's here, but also with economics, political science, issues of communication, understanding. And I think this is very important in terms of seeing the future in a more integrated way. If you look at climate change, which is my field, the biggest uncertainty in the climate for 2100 is not the uncertainty in the natural understanding of the system, it's the uncertainty as to whether humans will actually reduce our emissions according to 1, 2, 3, or 4 different scenarios. And those are the real complexities of these kind of issues. So I'd just like to say that the International Council for Science and the International Social Science Council, which will become roughly next July, the International Science Council, and we will jointly sponsor what was originally called the World Social Science Forum, to be held in Fukuoka, Japan, which is on the South Islands, in September 2018. And the topic, and here's the brochure, it's all over there by the water bottles, Security and Equality for Sustainable Futures. So I hope you'll all sign up and go there at that time. But let me just say that I think it's important that we don't, let's say, lose track of the fact that there, in addition to the Sustainable Development Goals, the global agenda includes the Paris Agreement on Climate Change, and also the, which is less well known, unfortunately, the Sendai Framework for Action on Disaster Risk Reduction. And I wanted to I was going to show the slide that Andrea showed, the second one, the circular one with water in the center. But I won't bother trying to get that up now. But if you looked at that slide at the bottom, it was Sustainable Goal number 17, which they were all sitting on. And that is partnerships for the goals, how to achieve them. And what we're trying to do with the International Council, the international science community, collectively across a whole bunch of organizations, but largely led by the International Council for Science, is to bring together the science community to address these issues in a more integrated way. You've heard of several examples of the Future Earth Research for Global Sustainability program. It's knowledge action networks. There are about a dozen of them being created in various ways around the world. Each of those are going to be linked together by the process. But we also have and have had since 1980 as co-sponsors the World Climate Research Program, which includes the Global Energy and Water Cycle Experiment. We also have a program which is less well known called Integrated Research on Disaster Risk. We'll have our science committee meetings in Japan the week after next. And the idea there is to bring together not only the issues of understanding the science, the natural sciences of a earthquake, volcano, and importantly a flood, which has been noted as one of the biggest causes of disasters, but also what we call risk interpretation to action. Based on the social, cultural, humanity, other kinds of issues, when people hear the warning, flood, flood, or in the case more recently in, say in Florida, hurricane, what do? Well, some of them say, hell with it, I'm not going anywhere. Other people go somewhere. Even the former governor of the state of Florida said, I'm not going anywhere just because the governor told us to evacuate our homes. So why do people do this? How do we understand and how can we convey our messages in ways that people will respond in a more, let's say, science, evidence-based policy kind of approach to something like a flood? As was also noted, we're having huge increases in the number of people in cities. And one of the big issues is urban health. So we actually have an international research program called Urban Health and Wellbeing, taking a systems approach. So if you look at these projects together, Future Earth, World Climate Research Program, Integrated Research on Disaster Risk, Urban Health, and others, we are trying to link them all together. The one common factor among those 4 projects is that they're all co-sponsored by the International Council for Science, and as the president, I've dictated to their directors, you either work together or else. We're going to disband you guys. I've been almost quite that risk. So I think there's a very important role to play in terms of bringing the science together, and we're trying to do that, but we need the support of all of you in working together and not trying to work too much in silos, but to work across these 17 Sustainable Development Goals, the Paris Agreement, the Sendai also has targets, and those kind of things, so that we can provide the evidence-based, science-based evidence for policy making. And that brings us to the issue, how do we get the policymakers to understand? Well, we've had the support of Sir Peter Gluckman and created the International Network of Government Science Advisors. The session after lunch today will be focusing on that. I think it's this afternoon, isn't it? Yes. So how do we better communicate? And I think we all have a responsibility. How many people here in this room have given a lecture to high school class in the last 5 years? But if you're not a school teacher, that is. I mean, I have. Right. I give them all the time. I also speak to seniors groups, seniors, to business clubs if they're willing to listen to me. And I think it's important that we not only, as we were talking about in one of the sessions yesterday, in our session of how do we evaluate science output, it's not only the paper in Nature that matters, it's the communication of science to the community, because I'm a former assistant deputy minister in the Canadian government. I spent 6 years trying to understand how politicians function that way, and I gave up after 6 years and went back to academia. But the important thing I learned was that the fundamental rule of all politicians was get yourself reelected. Now, why do they? So that means we have to get to the voters, not just to the politicians. We have to convince the communities that these kind of actions and provide the information to them in a way. And so we're, with the Council of Science and others, partners, working together with all of you here to communicate better the science for evidence-based policy, working with the Network of Government Science Advisors. Issues were brought up of the circular economy and the issues of data. And they're huge issues of data, openness, but at the same time, attribution as to who collected it, so that a PhD student doesn't spend 4 years of his or her life collecting all this data and discover when they're just about to submit their thesis that someone scooped it all and published a quickie in some obscure journal. So anyway, I'm getting off the track, but I thought I'd liven up the discussion before lunch. But let me just say that we want to work with the global science community, the meetings like the World Science Forum here, the one that Maureen is waving around there in a minute. Okay. There's a whole bunch of brochures over there. So let's sign all up for the one next year next September, in Fukuoka. Is that my pronunciation? Fukuoka. But also, of course, the World Science Forum, which will be in Budapest 2 years from now, approximately. But anyway, it's very important to bring the science community together, and we're trying to do that in a more integrated way across all the sciences. So as we say, science is a public good for the benefit of all societies, and we have to make sure that it's done that way in a productive way. That doesn't mean we coordinate all science. It means we bring together the community so they understand and work together. Thank you.
Thank you, Gordon. Well, I hope you've enjoyed the session this morning. Can I ask you to join with me to thank the speakers for some really great presentations. Thank you.